Let's look at the simpler function. So we are told classify all the critical points of f of x. Should be x cubed minus 3x plus y squared. Now the solution gonna come in 5 steps. So step 1, we have to find partial derivatives. So that is written as that. So what are the partial derivative of this function? So we start with dx of the function, that is 3x cubed minus, no, x to the power of 3 minus 3x plus 2y. So we have 3x squared minus 3 as our partial derivative with respect to x. Now what about with respect to y? So that would be 3 plus y squared. Now all the x here will be constant, and the derivative of a constant is always 0. So for this case, this one will give you 2x, no, 2y. So step 2, identify the critical points. This always happens when the partial derivative with respect to one of the variables is equal to 0. So we start with df over dx is equal to 0. So in this case, we have 3x squared minus x minus 3 is equal to 0. X here is equal to 1. So, but this one is a square, it can have 1 and 1. So negative 1 can be squared to make it positive 1. So value of x here, values of x is negative 1 and plus 1. Let's see for y. So this is 0. Then we have only y is equal to 0. So this means y1 and y2 are the same. So the critical points here are negative 1, 0, and positive 1, 0. So let's look at step 3. Step 3 is calculate second derivatives of the function. So let's start with respect to x. So the second derivative can be written like that. So this is the same as saying dx over times dx. So this is dx. Then we know the partial derivative of 4, which is that, is 3x squared minus 3. This will give you 6x. Let's do the y. So this is the same as saying df of dy. So we have known that already. So dy term of 2y will be equal to 2. Now we need to find that. So this is just saying dx of function dy will be equal to, but we know dy is right. Dy is 2, but with respect to x. So let's say dx 2, but with respect to dx, this will be 0. We built the discriminant equation. The meaning of this is just the determinant of these critical points. So dx dy dxy is equal to double derivative of function with respect to x times the derivative function, the double derivative of f with respect to y minus the double derivative of function with respect to x and y. So we already see here we have 6 times this one is 2, this one is 6x times 2 minus 0. We found this one to be 0. So now that is 12x. So let's go to step 5, which is the last one. So we have to classify all the points. And for this to happen, we have to evaluate dx at the critical points, or the point we found already. So critical point here 1. So at -1, 0, we have 12 is -12. So that is less than 0. This is local. No, this is saddle. Is where the function change, or the surface change, from curving up to curving down. So P2, which is 0.2, we have 1, 0. So that means 12 times 1 is equal to 12 greater than 0. This is local point, local minima, or local minima. So this is where the function curve up, or the surface curve up. That's all for today. Thanks for your time.